Hello friends. So we have a question on application of derivatives. In the first part we have to sketch a graph of function f. In the second part we have to find the inverse, and in third part we have to find the complex function h of g of x. So the question involves concepts of functions chapter and application of derivatives chapter. So let us try to solve the A part. In the A part we have to sketch the curve of fx, which is given as 1 divided by x square minus 2x minus 3. And we know x cannot be minus 1 and 3, as it will bring 0 in the denominator. Now when we draw a graph, we have to show asymptotes, any maxima or minima or the intersection points, etc, etc. So let us try to find the horizontal asymptotes for the curve. What are horizontal asymptotes? By horizontal asymptotes we mean the lines which are parallel to x-axis and the graph meets at those lines when x tends to infinity. So we have a graph y upon x square minus 2x minus 3. So this can be factorized as x minus 3 into x plus 1. So in this graph we know that as x tends to infinity, y tends to 0, and as x tends to minus infinity, y again tends to 0. Therefore, y equals to 0 is one of the asymptotes, one of the horizontal asymptotes. Now let us try to find the vertical asymptotes. How do you find the vertical asymptotes? Vertical asymptotes are lines which are parallel to y-axis, and in these cases y tends to infinity. So for the given function x minus 3 x plus 1, we know when y will tend to infinity, when either x tends to 3 or minus 1. So x equals to 3 and x equals to minus 1 are two vertical asymptotes. Correct. Now we will try to find the points of intersection with x's. So first let us try whether y equals to 0 is possible. No, because x is tending to infinity. We have already identified y equals to 0 as an horizontal asymptote. Now let us see, is x equals to 0 possible? Yes, if we put x equals to 0 in the function, we get minus 1 by 3 if we put x equals to 0. So this is one of the point on the, when x is 0, y is 1 minus 1 by 3. Now let us try to find any point of maxima or minima. So y is equals to 1 by x square 2x minus 3. So let us try to find the first derivative. So this will be 2x minus 2 divided by x square minus 2x minus 3 whole square. So we know at x equals to 1, we have a either maxima or minima. Now we know at x equals to 1, this term will be positive, and at x equals to 1, y dash changes sign from positive to negative. Y dash x is changing sign from positive to negative, and hence this will be a point of maxima. You can see in the question. Later on also this will be a point of maxima. Now let us try to draw the graph. We have one of the asymptotes at y equals to 0. Another asymptote is at x equals to 3. One asymptote is at x equals to minus 1. This is minus 1 comma 0. At x equals to 0, y is minus 1 by 3. So we have somewhere here 0 comma minus 1 by 3. So the graph would be passing through this point. And we have a maxima at x equals to 1. The value of y will be 1 divided by 1 minus 2 minus 3. So that will be minus 1 by 4. So at x equals to 1, the value is minus 1 by 4. So we have a maxima at 1 comma minus 1 by 4. This is your point at 1 comma minus 1 by 4. Now we also have to see what happens in the graph y equals to 1 by x minus 3x. When we approach from 3 plus x from the right hand direction, if we approach from the right hand direction, we will get 3 plus h minus 3, 3 plus h plus 1. So we would be getting towards positive infinity. So here it is touching towards positive infinity. And we know as x tends towards infinity, the value tends towards 0. So this graph would be in the green color, something like this. Something like this. Now if we approach x from the left hand side, putting x equals to 3 minus h, get is 1 by 3 minus h minus 3, 3 minus h plus 1. So this term is positive, this will be cancelled, this will be tending towards negative infinity. So that means the graph will be starting here on the negative side. And we know it moves up till it gets to this point, which is a maxima, and then it crosses this point, and we will see at minus 1 plus h, that approaching minus 1 from the right hand side, y will be 1 by minus 1 plus h minus 3 divided by minus 1 plus h plus 1. So this will be essentially moving towards negative infinity. And when we try minus 1 minus h, that is approaching minus 1 from the left hand side, we will be getting minus 1 minus h plus 1, and this will be tending towards plus infinity. So our graph will be something like this. This will be tending towards negative infinity, and from the left hand side it will start from the positive infinity, and we know as we tends towards x tends towards negative infinity, the graph approaches the value of 0. So this is your graph in the green color. These are your asymptotes. X equals to -1, x equals to 3, and y equals to 0. This is the point of maxima, and this is the point where the graph cuts the coordinate axis. So this is your graph. Now let us move on to the next part. So let us now move on to the B part. In the B part, we are given a function gx such that, if you notice, gx is the same function for which we have drew the graph in the first part, for which it is given that x is greater than 3. So in the B part, we are given a function gx which is 1 by x square minus 2x minus 3 such that x is greater than 3. Now if you see in the graph, if x is greater than 3, then this is the only portion of the graph which is possible in the domain, and hence y is also always positive. So what we can say is, if x is greater than 3, y is also greater than 0. Now in the function we have to find the g inverse x. So what we will basically do is, we are given y equals to x square minus 2x minus 3 with the constraint that x is greater than 3 and y is greater than 0. Now what we will do is, to find the inverse, we will replace x with y and y with x. So it will be something like this. And here y will be greater than 3 and x will be greater than 0 as we have replaced. So our basic conditions will be like this. So let us try to find the value of y in terms of x. So it will be something like x square y square xy square minus 2yx minus 3x minus 1 equals to 0. So we have a quadratic in y. We can solve by using the quadratic formula. So that will be y equals to minus b, that is minus 2x plus minus root under b square, that is 4x square minus 4 into x into minus 3x minus 1 divided by 2x. So what we get is y equals to 2x plus minus root under 4x square plus 4x into 3x plus 1 divided by 2x. So what we get is y equals to 2x plus minus root under 4x square plus 12x square, that is 16x square plus 4x divided by 2x. And if we see in the question, we have to solve and report our answer in a particular format, that is 1 plus something. So what we are getting is 1 plus minus root under 16x square plus 4x divided by 2x. So this will be 1 plus minus, if we take 4 outside, it will cancel our 2 and we will be left with 4x square plus x divided by x. So y is either 1 minus root under 4x square plus ix, or y will be 1 plus root under 4x square plus x by x. Now if we see our basic condition, y is always greater than 3. So if y is greater than 3, it cannot be 1 minus, it will y is greater than 3, so it cannot up with this. So the only solution left is y equals to 1 plus root under 4x square plus x by x. So this is our G inverse. Now we also have to find the domain of G inverse x. So to identify the domain of this function, what we can do is, first we know x cannot be equals to 0 as it is in the denominator, and the second thing is 4x square plus x is greater than 0. So what we get is 4x plus 1 into x is greater than 0. So from here we will get either x is greater than 0 or x is less than minus 1 by 4. But in the question when we started, we know x is greater than 0. So we will reject this. So we reject this. So the only domain possible for the given function is x greater than 0. Now let us move on to the next part. Now let us move on to the C part. In the C part, we are given a function h which is tan inverse x by 2, and we are also given that f of g of a has the value of pi by 4. So h of g of a is a complex function, composite function. We have to find the value of a. So what is gx? We know gx is 1 by x square minus 2x minus 3 with x greater than 3. So h of g of x will be h of gx. That means h of 1 by x square minus 2x minus 3. And this will be tan inverse 1 by x square minus 2x minus 3 into y. Now it is given that h of g of a is pi by 4. So if we put x equal to a here, it will be equals to pi by 4. That means inverse 1 by 2 into a square minus 2a minus 3 will be equals to pi by 4. That means 1 by 2 into a square minus 2a minus 3 equals to 1. So we have a quadratic in a, that is a square minus 2a minus 3 multiplied by equals to 1 by 2. So what we get is 2a square minus 4a minus 6 equals to 1, or 2a square minus 4a minus 7 equals to 0. Solving this for a, we get minus b, that is 4 plus minus root under b square is 16 minus 4 into minus 7 into 2 divided by 2a. So the values of a will be 4 plus minus root under 16 plus 7 into 4, 28, 56 divided by 4. So what we get is 4 plus minus root under 7 divided by 4. It can further be simplified as 1 plus minus 72 is basically 36 into 2. So 6 2 by 4, or 1 plus minus 3 by 2. So the value of a will be 1 plus 3 by 2 root 2, or 1 minus 3 by 2 root 2. Now we know when we defined gx, it was already greater than 3. The x has to be greater than 3. So any input a will have to be greater than 3. So rejecting this solution, we are left with only one solution, that is a equals to 1 plus 3 by 2 root 2. And in the given question, we have been asked that we have to express our answer in this format, p plus q by 2 root r. So let us try to find the value of pqr, that is p plus q by 2 root r. So if we compare, the value is 1, the value of q is 3, and the value of r is equals to 2. Simple comparison. So this is your solution. For more such questions, and register for detailed and solutions. Thank you.